All right. So don't forget the test is next week. Yes, end of next week. So we had 2 weeks-ish. All right. So let's start by doing example 8. I'm even going to do the examples. It says a crate of bananas weighing 3,000 newtons. So right away I can say FO, 3,000 newtons. Is shipped to South America, from South America to New York, where it is unloaded by a dock worker who lifts the crate by pulling with a force of 200 newtons on a rope pulley system. On a rope of a pulley system. All right, so the amount of input is going to be 200 newtons. Okay? What is the actual mechanical advantage of the pulley system? What's the actual mechanical advantage of the pulley system? We know that actual mechanical advantage equals FO over FI, correct? Yes? Yes or no? So what is the actual mechanical advantage? It would be 3,000 divided by 200 equals, these cancel, and I'm left with 15. So my mechanical advantage for example 8 is 15. Yes or no? You okay? I say yes or no a lot, don't I? When my son was younger, I would say to him, do you understand yes or no? And he would say yes or no. Okay. Okay? All right. That is example 8. Example 9. 2 clowns of mass 50 kilograms and 70 kilograms. So clown 1 is going to be 50 kilograms. And clown 2 is 75 kilograms. Correct? Respectively, are in a circus act performing a stunt with a trampoline and a seesaw. The smaller clown stands on the lower end of the seesaw, while the larger clown jumps from the trampoline onto the raised side of the seesaw, propelling his friend into the air. All right, so let me draw, I know, deadly. Yes? It's what? I can't hear you. 50 and 70, thank you. Thank you. All right, so this is called, what's that called? Anybody know? What's the triangle called in the picture? What is it? The fulcrum. The fulcrum. Right? The fulcrum. Okay? We've got to erase that to the location. And then I'm going to take this, and I'm going to go like this, and this is going to be, this is 2.4 meters, and this is 0.8 meters. Okay? Right? Yes? So let me repeat this. 2 clowns, mass 50 and 75 kilograms, respectively, are in a circus act, performing a stunt with a trampoline and a seesaw. The smaller clown stands on the lower end of the seesaw. This is the smaller one. So we're going to put M M1 here, and M2 there. While the larger clown jumps from a trampoline onto the raised side of the seesaw, propelling his friend into the air. A, what is the ideal mechanical advantage of the seesaw? That's A. What's the ideal mechanical advantage of the seesaw? DI equals what? What does DI equal? Come on, guys. I know it's early. It's only 10:30. You guys may still be in bed if you were home. What do we got? What's DI? It would be the larger one, right? Correct? So it would be 2.4 meters. DO equals 0.8 meters. Okay? So ideal mechanical advantage equals DI over DO equals 2.4 over 0.8 equals what? What is 2.4 divided by 0.8 equal? What is it? 3. Okay, good. Is that it? Okay, B. It says, if the larger clown exerts a force of 850 newtons on the seesaw as he jumps, how much force is exerted by the smaller clown? How much is exerted by the smaller clown? Well, you have to assume 100% efficiency. So FO DO equals FI DI. So what's FO? What's FO? What's FO? Oh, are we calculating FO? Calculating FO, right? So we have FI is what? 850, right? Because this is the FI, this is the work input side. This is the work output side. Okay? You get that? It's a little weird with levers. So this is going to be, what's DI? What's DI? 2.4 meters. What's DO? 0.8 meters. And then FO. So FO equals what? Was 850 times 2.4 divided by 0.8. What do you get? Okay, so that's numbers 8 and 9. Clear? Now let's turn that off.